Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are group 2 and we will be presenting materials on Gauss Quadrature. Let me introduce ourselves. My name is Arya Irawan and I'm not here alone. I'm joined by my teammates, Tryas Agiestya Putri, Nur Diana Faiza, and the last is Muhamad Faruq Osama. To start, I will explain the first part. So let's get into the explanation. What is Quadrature? Gauss Quadrature is a numerical method for calculating integrals by using special evaluation points at or nodes chosen based on the roots of orthogonal polynomials, such as Legendre polynomials. These points, along with appropriate weight, are used to calculate the integral as a linear combination of the function value at those points. The main advantage of this method is that it provide highly accurate result with fewer evaluation points, making it more efficient than other methods such as trapezoidal or Simpson, especially for smooth function without singularities. Next will be explained by Muhammad Faruq Osama.
Okay, thank you, Mr. Irawan. Here, I will explain about the algorithm of quadrature Gauss method. So the first step, we have to select the function and interval, specify the function f(x) to be integralized and the interval a and b. Then transform the interval. If needed, transform the interval a, b into a standard interval -1 and 1 by using variable changes. Then the step 3 is select evaluation point of node. Specify an evaluation point that is the root of an orthogonal polynomial, such as a legendary polynomial. Then, after that, calculate weight. Determine the appropriate weight for each evaluation point. And the final step is calculate integral. Calculate the integral as the sum of the function values at the evaluation points multiplied by their respective weight. Then the last step is obtain the integral result. The final result is the integral value calculated based on the above step. That is for the algorithm of quadrature Gauss method, and the next explanation will be explained by Mrs. Akis.
Okay, thank you, Mas Farouk. I will explain the advantage of Gauss Quadrature method. So the first is high accuracy. Gauss Quadrature provide more accurate result compared to other numerical methods such as trapezoidal or Simpson with fewer evaluation points. Second is efficiency. This method is more efficient in calculating integral as it can produce precise result with fewer points, especially for smooth function. The third is suitable for smooth function. Gauss quadrature is very effective for functions that have no singularity or discontinuity point. Fourth is speed for complex function. This method is also beneficial when the function to be integrated is very complex or difficult to calculate analytically. And the last is flexibility. The method can be used for different types of orthogonal polynomials and can be adapted for interval other than -1, 1. With this advantage, Gauss quadrature is an attractive choice for numerical integral calculation. The next presentation will be continued by Mbak Diana.
Thank you, Burgess. The next is disadvantage of Gauss quadrature method. Here are some topics of the Gauss quadrature method. First, not suitable for non-smooth function. This method is less effective for functions that have singularities, complexity of and weight determination must be done through calculation or taken from spatially tables, which can be complicated, especially for many evaluation points. Third is limited to polynomial representable function. The accuracy of this method decreases if the function cannot be well represented by a polynomial within a certain interval. Next. For its spatial interval require transformation. If the integration interval is not within minus 1.1, additional transformations are required which can add complexity to the calculation. 5. Less efficient for function with many discontinuities. Gauss Quadrature requires dividing the interval into several parts, which characterizes efficiency compared to other methods. This shortcoming can usually be overcome with modification or by using other methods for functions that do not fulfill the assumption of Gauss quadrature. I will pass it to Mr. Ayan.
Okay, now that we have covered the explanation of Gauss quadrature, we will present a sample problem that is solved using Gauss quadrature. After that, we will also provide the code used to solve the problem using this method.
The first question is Badan Pusat Statistik or BPS conducted a survey to analyze the distribution of population in Indonesia. For example, the survey results show that the distribution of population life in Indonesia can be estimated with probability function that have a similar form to Gauss function. Namely, fx is a power minus 0,5 x power 2, where x represents the age of the population in years and fx is the density of population age. Look for a percentage of residents who are at the range of 0 to 2 years with Gauss quadrature 2 point. The solve from this equation is like this. So we're gonna change the function to be Gauss quadrature function. When we use Gauss quadrature 2 point, so x1 is mean 0.577 and x2 is 0.577 with weight is 1. The formula is x p. The formula x is p mean a per 2 point x and then plus a plus b per 2. So we add x1 means 0.577 to this formula, and then we had x action 1 is 0.423. We also doing the same way to x2 to get x action 2 1.577. And then next, so after we get x, we substitution x into fx. So fx one action is 0.91442 and fx for x action 2 is 0.28838. So the population of age around 0 to 2 years is 1.2028.
Okay, in this section, I will demonstrate the application of the quadrature integral method. We have a problem here where we need to solve an integral with solve an integral. So for to shorten time, we can see the what is it? The question here. So we have time interval between 8 seconds until 30 seconds, and the actual value is 11 11,061.34. And then the function is integral 8 until 13 2000 learn and blah blah blah. We can see at the question. Okay, next. The first we convert the integration limits from 8 and until 13 to -1 until 1 using the general formula. We know that the general formula, like I'm writing before, we can see the in the screen, integral r until b function x dx, and then so on. What is it? Integral -1 until 1 function b minus a defined by 2 and times x plus b plus a defined by 2, and then times b min a defined by 2 dx. And the we have 8 and 30 before, right? And then we substitute to the formula. So ab is it's mean lab it's mean 8 until 30. The result of when we input 8 and 13 is 11 integral -1 until 1 function 11 times x plus 19 dx. Next. After we have the x1, x2, and x3, we can calculate the t1, t2, and t3. So for the t1, we use x1. So the x1 is minus 0.77458999 and 66692. So we substitute to the formula. So the result is 10,000. Say, iki piro yo? 10,000. 10 point ya?
Yeah.
Anjir, banget, Cok. Say, next one.
10.478874.
Okay. After we know the x1, x2, and x3, we can calculate the t1, t2, and t3. We have the formula before. It's a function with 11x plus 19. So we just substitute to the formula. For the t1, so we use the x1, and then the result is 10.4784 and 4. So for the x2, it's 0. So the t2 is 11 times 0 plus 19. So the result is 19. And for x3, we have 0.7745659666 and 92. So the T3 we substitute to the formula. So the result is 27.520.5 and 6. So we have the T1, T2, and T3. So after this, we want to calculate the function from T. Okay, next. Substitute to the calculate. Yeah, substitute to calculate function T. So for the function T1, of course we use the T1. We just substitute to the formula. So we have the function T is from before the question, right? So the result will be 9.0 I'm sorry, the result 239.3327. For the for the function T2, it seems like before T1, so the what is it, the function T1, so 19 will be this will be substituted to the formula. So the answer, the result is 484.7455. And then the T3, next. Okay, and the T3 seems like before. The T1 and T2, we just substitute the value of T3 to the formula. So the result is 795.1069. So after we have function of T1, T2, and T3, we can substitute to the formula of Gauss Quadrature. So here, uh, the what is it? The interval is 8 until 13. So just just do it. Interval 8 until 13. Function t dt. It's this from the formula, the general formula. So 11 is we know that we know before the result is 11 blah 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 blah. So this is an 11 and then C1 times function T1 and C2 function times function T2 and so on. So if we just substitute the result of T1, T2 and function T1, T2 and T2 to the formula. So the result 1000, 11,000 and 45, 48.8, 58.85. Next. So we have the result. We have the result of this question. So after that, we calculate the true error, the relative true error. Okay, we need true value. The true error is true value minus the approximate defined by the true value and then times 100. So the result of relative true error is 0.003%. Thank you. This is from my explanation. I'm sorry, my English is not too good. Thank you. And next.
Okay, I will explain how the Gauss Quadrature method with 4 point and is used to solve this question. So the question is, in a village, farmer calculate the harvested area of ornamental plants through 2023. Based on the data, the function of the estimate harvest area in hectare each month follow as mathematical model like that. With x is the time in months starting from January x equal to 0 to December x equal to 12. A student was asked to calculate the total harvest area of ornamental plants for 1 year using the Gauss Quadrature method with 4 point. It is known from the data that the exact value is 170 hectares. From the question, it can be seen that a equal to 0, b equal to 12, and the function is fx equal to 100 plus 400 times a negative power of x squared. And the initial integral is the integral of fx with respect to x from x0 to x12. The first step is we transform the integral limit to minus 1, 1. Since the Gauss Quadrature method works in the standard interval minus 1, 1, we can transform the initial integral with this formula. The first is x is equal to half time b minus a multiplied by t plus half time a plus b. And the second formula is dx is equal to half time b minus a multiplied by dt, with a equal to 0 and b equal to 12. Then we substitute the value of a and b, and the result is 60 plus 6, and the x equal to 6 dt. Thus, the original integral is the integral of fx with respect to x from x0 to x equal to 12 is transformed into 6 times the integral of f60 plus 6 with respect to t from t equal to -1 to t equal 1. And the formula integral becomes e approximately equal 6 times, open parenthesis, c1 time of fx1 plus c2 times fx2 plus c3 times fx3 plus c4 fx4, close parenthesis. Next, based on the table in Amos Gillette numerical method book, we use the weight coefficient and Gauss point coordinate for 4 points, like in this picture. The next step is to calculate the value of fx for each point. We substitute the x equal to 60 plus 6 into the function fx equal to 100 plus 400 times a negative power of x squared, so that the becomes f of 60 plus 6 is equal to 100 plus 400 times e negative power of 60 plus 6 squared. Next, we calculate the value of fx for t1, t2, t3, and t4. For the t1 equal to negative 0.86113631. The result of fx is 0.83318214. So we can substitute the x1 into the formula f x in the previous and the result is 299.79104. And the next for T2 is the same way like the for T. The result is 100.0006. Same way for T3, the F3 equal to 100, and for T4 is 102. After getting the value of x1 under the fx4, then we input the value of fxe and ce into the integral formula. So the result of E is equal to 1,616.9898 hectare. Then we compare with the actual value. The exact value is 170 hectares. Then the percentage error is 4%. Thus, the estimate total harvest area is 100 1,616,898 hectare with an error of 4 points from the exact value. So thank you. Is that from me? And I will return it in Mr. Arya.
Okay, the next session will go into the code explanation, which will be delivered by Faruq Osama.
Here I will explain to you about the code, and here I using JavaScript because JavaScript is my favorite programming language, so I can easily understand when I'm using JavaScript instead of like when I using Python. I'm more understand when I'm using JavaScript. So here let me explain to you. Here's I dividing the weight and the point like using array with object value. So I divide it 2, 3, 4, 5, 6 order with each value of for each order. For example, 2 order have weight value 1 and points minus 0 0.577350022 and so on and so on. Here's for the value I got from the book who Miss Uswa gave to us. Then here I will explain the Gauss Quadrature function. So the function needed 5 parameter, that is function A is for the bottom point, B is for the top point, order is for the order, and exact result is to find the error. Okay, find the value of weight and point. For this part, the system will find the search or weight and point according to what order user want. For example, if user input 2 order, so the weight and point will search from this data 2, so they got weight here and points is here. Then after that, here's for the error handling. If data doesn't exist, so the system will throw error with message like this. Sorry, message like this. Okay. Then if the data exists, the code will break down weight and point data from. So as you know, if we got this data, it's already using object in JavaScript. It's called object. So we have to define the variable for each variable one by one like this. So we got weight and points with different variable. Then transform function is to transform the function here, this function, into -1 and 1 function. -1 is for the A, B, and 1 is for the B. This for the formula. And divided 2 is continuing for this function. After we got all of this data, we can counting by counting the sigma result using for iteration or for looping. Looping will start from 0 index until weight dot length. Weight dot length is length for the weight. For example, if the user input order 3, so the weight will the weight value of weight is 3 because of there are 3 value in here. Okay, then the integral, then the formula is integral will add the integral with weight I, index I, then transfer function points I. Transfer function is here, so the point for each point will be transformed into -1 and 1 function. After we got all of this result of this data, we can find the error. The find error is simple actually, because we just have to calculate with exact result minus integral times divided by 2. So divided by 2 is, for example, is for the actual result, like cons final integral equals integral times divided by 2 here. But instead of I create new variable, I just write down in here. Okay, then error in percentage is for the percent. Then we have for this function, I want to return all of data, so I wrap all of the data into the result variable. Then I just have to return the result. For example, I use this data from Mrs. Agis. For the function is here, A is for the bottom point, and etc, etc. So to calculate, we just have to divide into with the variable. This Gauss Quadrature is here, and we just have to input all of the argument or parameter. After that, we already have the value. For example, here I use a Kuka, so I don't have to run manually using Node.js. I just using Kuka, so I can directly see the result for each console log here. Then here I want to know what the result of integral, so I just have to write the result dot integral. Integral is from here integral, so I got the data. But because of we just have to use 5 number after comma, we can add the function toFix. Then we got the value here. Here's for the result, here's for the error, and here's for the error of percentage. Okay, that's all from me. Thank you very much. I hope you understand what I explained about. I'm sorry if my pronunciation or grammar is bad. I'm still trying, I'm still studying, I'm still learning, so I hope you understand what I am talking. Thank you very much for your attention.
Okay, guys, that concludes our presentation on the example and solution using Gauss Quadrature. Thank you for your attention. See you. Wassalamualaikum warahmatullahi wabarakatuh.